Series. Today we are going to explore a crucial concept in managing data for distributed systems, which is data replication. Data replication is all about improving availability, redundancy, and performance by copying data from one database to another. Understanding how replication works can help you design systems that are resilient, responsive, and also capable of scaling effectively. So, what is database replication? In simple terms, database replication involves copying data from one database server, often called a primary or master, to one or more additional servers, known as replicas or slaves. This approach creates multiple copies of your data across different servers, providing several benefits. We will talk about them, but let's just make an example to understand how replication works. So let's say that we have a system, we have a client, and this client sends request to our server, and the server sends read and write operations to our DB. And for now, let's assume that we have one database server, only one database server. So if this database server went down for any reason, we will lose our data. If the server sends a lot of requests to our database server, our data might get overwhelmed. Okay. Also, if we have like if we have we might have like a risk of losing data due to like hardware failures. We might lose the data because we only have one database server, so we have a single point of failure. We need to improve the availability and the performance and the fault tolerance of our database server. So how we do that? We will go with replication. We can work with a master slave replication. So how this will work? Instead of having one database server, we will have three database servers. Why it doesn't have okay. And let's just do it again here. Yep. Okay. This one. So we will have the first one, which is a primary or master. And let's make the master big. And we will have two slaves. Slave, slave DB1, and we have slave DB2. So when the server tries to write requests to the master database, the master database will write the request and it will replicate all the data in the two slaves. So if let's say that the client added a new user called John, for example. So the master will take this data and will replicate them into the slaves. So we will replicate the data across three servers right now. So if the master went down, okay, the other slaves have the data and they can work, and one of the slaves could be promoted as a master and could serve the server. So we improved the availability by then. Also, we can improve the load balancing. How this will work? By if the master is only serving the right requests, okay, and the slaves will serve read requests. So whenever the server needs to read something, it will go to the slaves, not to the master. That means the load will be distributed across different servers, which will make some sort of load balancing. Like by distributing the read operation across multiple replicas, you can significantly reduce the load on the primary server. This particularly important for systems with a lot of read heavy traffic, where offloading reads to replicas can improve overall performance and reduce response time for users. So right now we improve the performance and the load balancing, and also we have high availability now, because one of the biggest advantages of replication is that it ensures it ensures your data remains accessible even if one server fails. If the primary database goes down, a replica can take over, which helps maintain uptime and keep your application running smoothly. Also, we help in fault tolerance because with multiple copies of the data or data stored across different servers, the risk of losing data due to hardware failures is minimized. This redundancy is a key for building resilient systems where data durability is critical. So there is multiple types of database replication. Each one has its own use cases and trade-offs. The first one is the master-slave, and I guess this example of a master-slave replication. In a master-slave replication, one server acts as a master that handles all write operations, while one or more slaves serves handle one or more slaves servers handle the read operations. The slaves are updated by replicating the changes made on the master. This type of replication is good for improving read performance, but comes with challenges if the master fails, since you would need to promote a slave to take over to and be in the new master. There is also a master. So basically, instead of having one slave, we could have like, let's say that we will have two masters for now, because I don't want to complicate it. And we can send it like that. We could have two master databases that will try to replicate the data between them. Like, it will send the replicas like that, and it will send from here. It will goes like that basically. So the master application, two or more servers can handle both read and write operations, and the changes are propagated between them. This type of replication can be complex to manage, especially when dealing with conflicts between writes, but it provides high availability and redundancy, as any master can take over if another one fails. There is also synchronous vs asynchronous replications. Like, synchronous replication ensures that data is written to both the primary and replica servers at the same time. This guarantees consistency, but it can add some sort of latency because the system needs to wait for the data to be written to all replicas before confirming the write. And we have asynchronous replication, on the other hand, allows a primary server to perform a write as soon as it's completed locally, while the replicas are updated in the background. This approach reduces latency, but comes with the risk of temporary inconsistencies between the primary and the replicas. So that's it for this one. I hope you like my video. If you like my video, make sure to subscribe and hit the notification bell so you'll never miss a video. And see you guys in future videos.